Thank you, Bogdan, for the very energetic intro. You took half of the time of my talk. Yeah, hi everybody. I'm excited to be here, and to be honest, quite a little bit nervous. But let's talk about one of actually the king of the buzzwords nowadays, artificial intelligence. So I expect that not every one of us is actually training AI algos on a daily basis. So I'm not gonna go. The presentation is not gonna go into tips and tricks onto how to better train those kind of models. But instead, I'd like to give you a brief overview of the dynamics of the life of an AI engineer slash researcher. And probably some of you actually thought at some time, how would it be like to be an AI engineer? And probably after the presentation, you will get a better idea. That's the objective. So, as you might have guessed, I like artificial intelligence, but I also like memes. And there's this one that has been circling around the internet for quite some time. And it's basically mocking the product companies that wanted to jump on the AI hype train, but they fundamentally just use probably simple rule-based algorithms or stuff like that. And I think since we're in 2024, there's generative AI and all kinds of stuff. It needs a little bit of update. So I try to do that. And I think nowadays it's way easier for those kind of companies, startups especially, to just use an API. What cloud provider nowadays doesn't have a generative API? Yeah, to claim innovation. I'm not saying that using API is bad in the same way that I'm not saying that using ifs analysis is bad. It's just a very important distinction to be made, especially when talking about product companies, when talking about innovation, intellectual property, and yeah, differentiating yourself in the market. So I'm not going to focus into using and calling APIs, but instead I'm going to focus on the opposite side, on actually building not necessarily the APIs, but the models behind it, how the life of such a developer looks like. But before that, I need to get to a little bit of context of where my experience comes from, and yeah, what are the biases of some of my opinions, let's say. So as Bogdan was telling you already, I'm the co-founder of Rayscape, which is a startup assisting radiologists. That means we're obviously a product company, and we're basically a startup, still small startup. So a lot of my insights and what I will be sharing with you will come from this kind of perspective. So be aware some of my opinions could be skewed in that regard. So we have been building AI models. We have been training hundreds of AI models in the last 7 years, especially in the subfield of computer vision that spans all kinds of subtasks such as detection, localization, image classification, image-to-image translation, segmentation, and so on. So all that's implying computer vision, we have tried some flavor of that at some point. We've done all the mistakes that could have been done and learned some of the lessons from there. But building those products could not have been possible without going into a lot of research. And you'll be hearing me saying a lot more the word research in the following minutes. So one could fairly ask, Bogdan, but I don't want to build a medical company. Do I really need to get into research? Do I really need to wear a white lab coat? Well, the answer to that would be that the good news is you can get away without the white coat, but you cannot get away in AI without research. So to understand that better, I think it's time to paint the profile of some of the main roles in artificial intelligence. So what's an AI engineer and what's an AI researcher? So obviously both of them have in common the fact that they both train AI models, and not only that they train AI models, but they try to model a task. The first difference comes in what type of task that is. Thank you. The engineer has to be always pragmatic. His task is to ultimately deploy something that will be useful, which means they have to think about stuff like the inference time. You cannot expect a self-driving car to take 3 minutes to make a decision. He have to think about what kind of data he can get his hands on. While on the opposite side, the AI researcher cannot or have to stay within some data boundaries. So for example, most of the AI research is being done on public benchmarks, established benchmarks on each of the subtasks. So there's a fixed training data set, a fixed validation data set, a fixed metric on which his new method that he researched and developed and probably will publish is needs to be measured on. And this is in some ways very restrictive, and it's totally opposite from the engineer, which if he doesn't like the metric, he can change it, and probably 80% of his time will be spent on adding more data or cleaning the data or stuff like that. Why is that? Because let's think about what it means to bring an improvement to your task. On the job of the AI researcher, he will probably have to come up with a new technical way, probably let's take the example of a new neural network architecture that has never been taught, and he will probably have to build that on top of already existing architectures that have been iterated by 1,000 other researchers. So the improvements are very iterative and are very rare and hard to squeeze. While on the other side, basically when you get a new data set, nobody done anything with it. So there's a lot of improvements, a lot of performance to be squeezed from there. So this, we can talk about all day about differences, but this would be the main differences. So then there's a question, okay, but can I just be the engineer? Well, the answer is not really. Because in practice, it's very rare that those profiles are that ideally and clearly defined. It's rather a combination of both in different degrees. So for example, I identify myself as being right in the middle. I claim to be an AI research engineer, and that's actually how the most common role in the industry is called, AI research engineering. Okay, but there's some companies that also actually have AI engineers. Can I be one of those and just stay away from research? The answer again is no. Why is that? Because the AI engineer cannot keep up the pace with the industry just by looking at blog posts and YouTube tutorials. The field is so fast-paced that the only place you can get your information and you can stay up to date with the field is from scientific articles. You have to read scientific articles probably daily, and you have, yeah, it's basically part of your job, no matter you're a research engineer. That's why I'm so focused on research on this presentation. So here comes one of the first distinctions to be made here in the presentation, and it's data-driven R&D versus model-driven R&D, what we were discussing before. Usually data-driven is associated more with the engineering side of the AI, and the model-driven is usually associated with the research side of things. That again is an ideal distinction. In practice, it's not that it's not always like this, and the researchers are not staying only in academia anymore. The industry have realized the importance of AI PhD and AI researchers, and I can't remember who actually come up with this code, but it just stuck with me. And again, from the filter of an AI startupper and somebody that worked all his life in a product company, the AI researchers are now driving the innovation in those kind of companies and are getting the attention of the VCs, and this is where basically the money comes. So we've been seeing a switch from academia to industry, and there's been quite a large flow of money that companies are throwing on AI researchers right now, especially in developed hubs. We're talking about Silicon Valley. This is actually one of the biggest problems of the companies right now in Silicon Valley, not necessarily raising money, but finding top talent to burn that money on. And this is how, news like this come up. And top talent is not the only thing that gets money thrown at by investors right now. Also, we've all probably been hearing about computing power. So we're talking about clusters that the big guys are discussing about collocating with nuclear powers. It's probably very hard to put things in perspective, but I'll try anyway. So for example, the computing cluster that Elon Musk just put together recently is made up of 100,000 age-suited GPUs. This is state-of-the-art GPUs. So for example, only one of those, H100, is more powerful than everything we've ever used to train a model, any model, in Rayscape. So with only one of those, you can basically build Rayscape in terms of computing power. And he has 100,000 of those. And that's just the beginning. This, as you might imagine, also creates some problems and basically a disparity between the big tech and the other smaller players, because a big chunk of research and innovation has overnight become available to only a handful of companies. Does that mean that the small companies are impossible to be made, to be built? No. But what I personally think is that it's becoming increasingly more difficult to build a company from scratch with just an idea. So if a few years ago you could have dreamed the idea of Airbnb and built a web app in your dorm room, even when we started Rayscape, actually, the first algorithms that were actually state-of-the-art in the literature back then were trained on this laptop alone, no other GPUs. You cannot do that now. You basically need money to start a startup now, which was not the case a few years ago. It's getting increasingly difficult. Hopefully, this gap might have a solution, which is open source. I told you I'm into memes. If you're not into Romanian politics, not to say Russian, then obviously I'm ironic about saying that open source is the solution that will solve all this disparity between the big tech and the other smaller players. Why is that? Let's take the example of Meta, which Meta, out of the big tech guys, I love Meta the most because they basically committed to open source. They basically, all the AI they've been training, they've been making it publicly lately. And we've actually been using at Rayscape some of their code base. And why am I saying then there's still a problem in the open source and cannot cover the problem entirely is because we have to ask, what does open source mean in AI? Is the code base made available? Yes, Meta sometimes does that. Then, are the model weights made available? The answer again is yes. Meta sometimes does that and have done great things making the largest open source LLM available. But the problem comes when you ask, is the data open source? And the answer is not. And what does this mean is that while you can promote yourself as an open company promoting open source and helping the industry, which you are actually doing, and you actually are a good guy, at the same time, you're protecting your intellectual property and you're protecting yourself so that at any moment you can say stop, and then the open source and the research, 90% of the research community would just freeze in time and would get stuck with the latest LLM that Meta made once in the past public, and that would be not enough comparing to what the other big guys are doing. So yeah, open source is definitely not enough. And the gap is still growing. So that's it. You've been hearing me talk about research a lot. So why is that? Because it's getting increasingly, research in AI is getting increasingly more popular. This graph is only until 2019, but spoiler alert, it just keeps on growing. And it also has some interesting consequences in the industry. So basically, this is the top from Google Scholar of the most impactful research avenues a researcher could publish in, not only AI. So up until very recently, you would see just the legacy journals, Nature, Science, everybody heard of those. These are the type of journals that are around by literally hundreds of years and have been publishing Nobel Prize level research. And interestingly enough, the new AI conferences, not even journals, conferences, are getting very close, sometime overcoming in terms of the scientific impact to those. So take, for example, number 10, which is a conference called ICLR, which you probably never heard of if you're not into AI. But already passed JAMA, which is one of the most powerful scientific magazine in the world that's been founded in the 19th century. And for me, it's also surprising since the main contributors to the other journals are doctors, physicians, and you would expect doctors and physicians to want to meet physically and discuss, I don't know, the lives of patients and how to save those. Instead, the AI geeks are the ones that prefer to gather at conferences and discuss, I don't know, how to better generate cat memes or something like that. So it's a little bit counterintuitive if you ask me. For the sake of time, we'll be skipping those. But there's also some consequences to this alert rhythm of publishing in the literature, and actually the pressure of publishing in the literature. So there is funny consequences and there's not so funny consequences. So for example, on the top side, you would see the last 4 articles just published recently in Nature. You would see what you would expect from article from reputable scientists publishing in Nature, formal titles, serious language, as opposed to what you would see on the bottom side, where AI geeks basically use puns and they do whatever they want when they want to name a paper. Okay, but you can say those might be cherry picked because those are not very important papers. These could be low tier paper. Actually, Attention is All You Need is one of the most influential paper of all time, gathering probably around 150,000 citations overall, and it is actually the bedrock, the foundation of the generative AI trend and the LLMs. So still, the naming conventions were very interesting, and it's obvious it was done by AI geeks. Those were the funny consequences, but there's also some serious consequences in terms of publishing fake stuff, publishing stuff that is not reproducible, which is actually one of the main points of research. And a lot of shady money not going into the right pockets, let's say, because keep in mind, not the scientists are not paid. The scientists that publish are actually paying the journal, and the ones that review the articles are not paid. They do that just voluntarily, and still, it's a very big industry. Okay, one of the last things that I want to touch is a question that I often get asked a lot by people that actually consider into getting into AI is, do I really need to know math? Do I need to be good at math to get into AI? And the simple answer is no. And I would go even further and say that it seems that you don't even need to know computer science or engineering to get into AI. Why am I saying that? Because there's a very recent trend of physics graduates that switch to AI PhDs. This is not very common in Romania, but it's very common in the most prestigious of universities worldwide. And we've seen a lot of physics graduates that published very, very powerful papers in artificial intelligence. And why am I saying that you don't also need math? Is because while reading articles such as this one, which is actually an average article that I just read last week, you probably would see very scary looking mathematics, and you would just hit close and switch, I don't know, to Android applications or something like that. But in fact, you need to be aware that the AI geeks that write these kinds of papers are very full of themselves and try to just look smarter, which I'm guilty of as well. So for example, here, what's that hypersphere and all those formulas is just a fancy way of saying that in a vocabulary, which is the sphere, every word have a different similarity to every other word. Some words are more similar, some words are not. And you could formalize this kind of similarity to an angle in geometry, in algebra, in linear algebra. And you would simply measure, you would formulate a formula that would simply measure the similarity between those words, which is exactly what this thing does, by calculating the cosine of those vectors, which are the words. That's all there is to it. And you can learn that in literally the first hours of linear algebra in the first year of university. And that's the maximum amount of mathematics that you need to get into AI. So if you can learn it in the few weeks of university, I'm sure you can actually learn it in along while learning AI. So you don't need a prerequisite of being an Olympic in mathematics. Right, so the last thing that I want to go through is what are some of the tools and differences between general software engineering and AI engineering is probably the biggest difference of all is the framework of thinking about writing software, writing code. So if you're used to writing scalable, clean code, good job for that, but you can throw it away when switching to AI, because 90% of the code that you'll be writing will be in the form of scripting that you'll be throwing away, because it's just so much experimentation So much visualization, interactions, you just want to switch from the other. I literally have in a project of mine a file that's called spaghetti.py. Of course, there's exceptions to that. If you want to write frameworks, for example, for others to use, you need to know how to write better code. It's just inefficient to think of scalability when scripting and trying to experiment with those kinds of AI training loops and playing with the data. Of course, playing with the data also means lots of visualizations, which uses dedicated libraries to that, and also frameworks. So a quick advice here is if you actually get into AI, you will probably come across a lot of tutorials on TensorFlow, which was popular at some time and still is, but 90% of what is happening now is happening in PyTorch. So just go to that to save you some time. And lastly, there's the dashboard in which you visualize how training is going. If you're training something for, I don't know, hours, days, or even weeks at the time, you want to make sure real time that the thing are going into the right direction. That's the reason some of my colleagues are laughing at me, because all I do all day is just look at the graphs and visualizations. Yeah, so that would be all. I really hope that you got something useful out of all of this, and if you are interested in finding any more about it, or you have any questions, I will be waiting for you. I'm eager to discuss with you. Thank you very much.